Hello, everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I read the summary of the report on LMN, and I'm eager to learn more about it. Could you please explain the concept of LLM inference and how it works?
Certainly. LM inference refers to the process of using a pre-trained neural network model to generate text. It is like having a really smart computer program that can predict what words should come next, in a sequence based on the words that have already been given to it. Imagine you have a storybook, and you want to know what the next word should be after reading a few sentences. The LM model works in a similar way. It takes in a sequence of words and uses its trained knowledge to guess what the next word could be. It does this by looking at patterns and similarities in the text it has been trained on. Once the LM model has made a prediction for the next word, it continues the process by feeding that predicted word back into itself and making another prediction. It keeps doing this until it has generated the desired amount of text. This process is like a computer that keeps generating sentences based on the words it has already produced. It's like the computer is dreaming up new stories or writing its own book.
That's fascinating. So, LM inference essentially involves using a pre-trained neural network model to generate text by predicting the next word in a sequence based on patterns and similarities in the training data. It's like the model is dreaming up new stories or writing its own book. I'm curious, how is the LM model trained in the first place? What kind of training process and data are involved?
The training of the LM model is a complex process that can be best understood as a compression of a large chunk of the internet. To obtain the parameters of the model which are crucial for its functioning, a significant amount of text data is used. This chunk of the internet can be roughly around 10 terabytes of text. The training process, also known as model training, involves feeding this massive amount of text data into the model. The model learns from this data by analyzing the pattern, relationships, and context within the text. It tries to understand the language and predict the next word in a sequence. During training, the model goes through iterations, adjusting its parameters based on the patterns it observes in the data. The goal is to optimize the model's ability to generate coherent and contextually relevant text. It is important to note that the training process is highly involved and resource-intensive. It requires powerful computational resources and significant time to train the model effectively. However, because LMM is an open-source model, the process and details of its training are publicly available, allowing researchers and developers to understand and build upon it.
Thank you for explaining the training process of the LM model. It's impressive how it can compress such a large chunk of the internet and learn from patterns in the text data. Now, I'm curious about the concept of fine-tuning. How does fine-tuning work with the LM model? How can it be customized for specific tasks?
Fine-tuning is an important process in training the LM model and customizing it for specific tasks. It allows the model to improve its performance on a particular task by incorporating task-specific data. Here's a simple metaphor to explain how fine-tuning works. Imagine you have a robot that can do various tasks like cleaning, cooking, and gardening. Initially, the robot is trained with general knowledge and skills that apply to all tasks. This is similar to the pre-training stage of the LM model. However, to make the robot more efficient and effective in a specific task, you can provide it with additional training on that task. For example, if you want the robot to specialize in gardening, you can give it training specifically related to gardening techniques and knowledge. In the case of the LM model, fine-tuning involves exposing the model to task-specific data during the training process. This data helps the model learn patterns and information relevant to the specific task. The more task-specific data you provide, the better the model can understand and generate accurate predictions or responses for that particular task. The advantage of fine-tuning is that it is a relatively cheaper and faster process compared to the initial pre-training stage. This allows companies to iterate and improve their models more frequently. By fine-tuning the LM model, it can be customized and optimized for different tasks. making it more versatile and effective in solving specific problems.
Thank you for the insightful explanation of fine-tuning with the LLM model. It's fascinating how the model can be customized and optimized for different tasks by incorporating task-specific data during the training process. I'm curious about the concept of LM scaling laws mentioned in the summary. Could you please elaborate on what LMN scaling laws are and how they relate to the model's performance and capabilities?
LM scaling laws refer to the relationship between the size of the language model and its performance and capability. In simple terms, as the size of the LM model increases, its performance and capabilities also improve. According to the report, there are several scaling laws that have been observed. One such law is the compute rule, which states that when the model size is increased by a certain factor, the compute required to train the model also increases by a similar factor. This means that larger models require more computational resources for training. Another scaling law is the dataset rule, which suggests that as the model size increases, the amount of training data required also increases. This is because larger models have more parameters that need to be trained, and a larger dataset is needed to effectively optimize these parameters. Additionally, there is the quality rule, which states that larger models tend to generate higher quality output. This is because larger models have a better understanding of language and can capture more complex patterns and nuances. Overall, LM scaling laws show that increasing the size of the model can lead to better performance and capabilities. However, it is important to note that there are practical limits to model size due to computational constraints and the availability of large-scale training data type.
Thank you for explaining the concept of LLM scaling laws. It's interesting to see how increasing the size of the language model can improve its performance and capabilities. But it's also important to consider the practical limits imposed by computational resources and the availability of training data. I'd like to delve into the topic of LM security mentioned in the summary. Could you please provide an overview of LM security and some of the potential risks or vulnerabilities associated with it?
LM security refers to the security concerns and considerations surrounding the use of large language models, LMs. LMS are powerful AI models that can generate human-like text and perform various natural language processing tasks. While LMS have shown tremendous potential in various applications, they also pose certain risks and vulnerabilities that need to be addressed. One potential risk is the generation of malicious or harmful content. LMS can be fine-tuned or customized to generate specific types of text, which may include misinformation, hate speech, or other harmful content. This raises concerns about the misuse of LMS to spread false information or propaganda. Another vulnerability is the potential for bias and discrimination in LM output. LMS learn from vast amounts of training data, which may contain biases present in the data. As a result, the generated text by LMS may reflect or amplify existing societal biases, leading to unfair or discriminatory outcomes. Additionally, LMS can be susceptible to adversarial attacks. Adversarial attacks involve manipulating the input to an LM in a way that causes it to generate incorrect or unintended outputs. These attacks can be used to exploit vulnerabilities in LMS and deceive their prediction, potentially leading to misinformation or fraud. Furthermore, there are concerns about the privacy and security of the data used to train fine-tune LMS. LMS require vast amounts of data, often including personal or sensitive information. If this data is not properly protected, it can be at risk of unauthorized access or misuse, potentially leading to privacy breaches or data leak. It is important to note that LLM security is an active area of research, and efforts are being made to address these risks and vulnerabilities. Researchers and developers are exploring techniques such as robust training, bias mitigation, adversarial defense mechanisms, and privacy-preserving methods to enhance the security and trustworthiness of LMS.
Thank you for providing a comprehensive overview of LM security. It's crucial to address the potential risks and vulnerabilities associated with LLMs, such as the generation of malicious content, biases in outputs, adversarial attacks, and data privacy concerns. I'm glad to hear that researchers are actively working on mitigating these risks and developing techniques to enhance the security and trustworthiness of LMS. I'm curious about LLM customization mentioned in the summary. Could you please explain what LLM customization entails and how it is implemented?
LLM customization refers to the ability to tailor a large language model, LLM, to specific tasks or domains. It allows us to make the LLM an expert in a particular area by fine-tuning its capabilities. To implement LLM customization, OpenAI has introduced the concept of the GPT's App Store. This allows users to create their own customized versions of the GPT language model. Currently, customization options include adding specific custom instructions or uploading files to enhance the model's knowledge. The customization process involves modifying the parameters of the neural network that forms the LM-2. These parameters are like the instructions that the model uses to generate text. They represent the weights and settings that determine how the model functions. Additionally, there is a separate code file called the run file that is responsible for running the neural network with the modified parameters. In summary, LM customization involves adjusting the parameters of the language model to specialize it for specific tasks or domains. And this is implemented through the GPT's App Store by modifying the parameters file and using the run file to execute the customized model.
Thank you for explaining the concept of LLM customization. It's interesting to see how users can tailor the large language model to specific tasks or domains by modifying the parameters of the neural network and using the GPT App Store. This allows for greater flexibility and specialization in utilizing the LM for various applications. I'm curious about the concept of LMOs mentioned in the summary. Could you please elaborate on what LMOs is and how it relates to the functioning of the language model?